Good morning to all. Today we are discuss about power system analysis problem number 7. Write a short notes on fault current in synchronous machine. Second one, what are the assumptions made in fault analysis? The following assumptions are made for fault analysis. First one, each synchronous machine is molded as a constant voltage source behind reactance. The reactance value depends upon the period, which may be xt double dash for subtransient or xt dash for transient period or xt for steady state period, where xd double dash subtransient reactance, xt dash transient reactance, xt is equal to steady state reactance. Second one, pre-fault voltage for unloaded system is assumed to be 1 volt angle 0 per unit. The shunt element in the transformer model that accounts for magnetizing current and core loss are neglected. Then fourth one, pre-fault load currents are neglected. Then fifth one, shunt capacitance of the transmission line are ignored. Then sixth one, all series resistance of generators are neglected. Then seventh one, a symmetric three-phase power system is considered. The assumptions are generally made to reduce the calculation. Then eighth problem, construct a Z bus using bus building algorithm. In this bus algorithm, the diagram it will be represented for first bus to second, second to third. It will be connected in series J 0.25 1 to 2, then 2 to 3 J 0.08, and in between the parallel connected to the reactance J 1.0 and J 1.25. Step 1, adding an element J 1.0 between reference and bus 1. That is called Z bus equal to J 1.0. Adding a new bus to the old bus 1 and 2 type. Then 1 is a J1 and reactance of the in addition to the 1 to 2 J 0.25. Then Z bus equal to J 1.0 and 1.0 and 1.0 and J 1.25. That is equal to Z11 plus Zs equal to J 1.0 plus J 0.25. Adding an element between 1.25 between old bus 1 and reference type 3. In between the element of 1, 2 and the reference bus of the 3. In this type J 1.0 and then 1 to 2 J 0.25 and another 2 to reference is a 1.25. Then Z bus equal to 3 into 3 matrix equal to then 1.0 J 1.0 J 1.0 J 1.0 J 1.25 J 1.25. Then third row J 1.0 J 1.25 and J 2.5. Then ZKK plus ZS equal to Z22 plus ZS equal to, that is J 1.25 plus J 1.25, that is equal to J 2.5. Apply current reduction because of no new node added. Zij new is equal to Zij Zip into Zpj divided by Zpp. That is equal to Z11 new is equal to Z11 old minus Z13 into Z31 divided by Z33. That is equal to J 1.0 minus J 1.0 J into J 1.0 divided by J 2.5. That is equal to J 0.6. Then Z22 new is equal to Z22 old then minus Z33 minus Z32 divided by Z33 is equal to 1.25 1.07 into J 1.25 divided by J 2.5, that is equal to J 0.625. Then Z12 is equal to new is equal to Z12 old minus Z13 into Z31 32 divided by Z33, that is equal to 1.0 minus J 1.0 into J 1.25 divided by J 2.5 is equal to 0.5. Z bus equal to 0.6, 0.5, 0.5 and 0.625. Then step 4, adding the element J0.05 between old bus 2 and new bus 2 type 2. And between the reference node of the 3 into 3 matrix Z bus equal to 0.6, 0.5, 0.5, 0.625, 0.625, 0.5, 0.625, 0.75. That is equal to Z22 plus ZS equal to J0.625 plus J0.05 is equal to J0.675. The next one is a 4-bus sample power system is shown in figure. Perform the short circuit analysis for 3-phase fault on a bus 4 are given below. G1 is equal to 11.2 kV 100 megavolt ampere, X equal to 0.0 per unit. G2 is equal to 11.2 kV 100 megavolt ampere, then reactance is equal to 0.08 per unit. Transformer T1 is equal to 11 divided by 110 kV, then 100 megavolt ampere, reactance is equal to 0.06. Then transformer 2 11 per 110 kV, 100 megavolt ampere, reactance of 0.06 per unit. Assume pre-fault 1.0 and pre-fault current to be 0 and take the fault the impedance. That is in the solution for by building algorithm. In this diagram will be represented for generator 1 and 2. In the node reference 1, 2, 3, 4. It is a transformer and transformer 2, 1 to 2. It will be the connected in the reactance J 0.20 and J generator 1 and 2 J 0.20 and fault is the J 1.0. J 1.0 1 2 4 3 2 4. It's a same value of J 0.10. By algorithm, Z bus J is equal to then 4 into 4 matrix 0.150, 0.075, 0.140, 0.135, 0.075, 0.1875, 0.090, 0.0975, 0.140, 0.090, 0.2533, 0.210, 0.135, 0.0975, 0.210, 0.2475. For the fault bus 4 with the fault impedance Zf is equal to J 0.0225 per unit. The current is fault current if 4 divided by Z4 44 plus Zf is equal to 1.0 divided by 0.2475 plus J 0.0025, that is equal to minus J4 per unit. The bus voltage during the fault are, first one is a V1 fault is equal to V1 minus Z14 I4 into value of 0.46. Then V2 fault analysis is equal to V2 0 Z2 4 then into I4 is equal to 1.0 minus J 0.0975 into minus J4 is equal to 0.61 per unit. Then V3 fault is equal to V3 0 then Z minus Z34 into I4 is equal to 1.0 in minus J 0.2010 into minus J4 is equal to 0.16. Then V4 is equal to V4 minus Z4 into I4 is equal to minus J 0.2475 into minus J4 is equal to 0.01 per unit. The short circuit current in currents in the lines are I13 fault is equal to V1F minus V3F divided by Z13 is equal to 0.46 minus 0.16 divided by J 0.02, that is equal to minus 1.5 per unit. I14 is equal to V1 minus V4 divided by Z14 is equal to 0.46 minus 0.01 divided by J 0.03, that is equal to J minus 1.5 per unit. Then I21 is equal to V2 minus V1 divided by Z21, that is equal to 0.61 minus 0.46 divided by 0.5 is equal to minus J 0.3. Then I24 is equal to V2 minus V4 divided by Z24 is equal to 0.61 minus 0.01 divided by J 0.6 equal to, that is minus J 1.0 per unit. Then I34 is equal to V3 minus V4 divided by Z4, that is equal to 0.61 minus 0.01 divided by J 0.10. That is equal to J minus J 1.5 per unit. Thank you.